Hello everyone, welcome back to another video of integration. So from the past lesson, on the last video that I made, we talked about integration of trigonometric functions. But in this video, we will talk about integration of transcendental function. When we say transcendental function, those functions that contains logarithm, natural logarithm, exponential, that's e function. So this is the integration rule for integrating transcendental function. If we have the integration of u1 over u du, then that is the natural logarithm of u plus c. So if we satisfy this form, okay, when we have our u, again, that is any function, then if we have the derivative of u at the numerator, then we use this rule, that is the natural logarithm of the absolute value of u plus c. Now, for the integration of the exponential raised to u du, then that equals to eu plus c. So it is the same as with the differentiation. If you differentiate eu, that would bring us to eu itself, okay? So if we differentiate e raised to x, if we differentiate e raised to x with respect to dx, that would give us e raised to x, tama? But if we integrate e raised to x dx, that would give us e raised to x plus c. Our c there is at any constant. Okay, so just memorize this integration rule for transcendental functions. Okay, let's solve problem. We have the integration of 5 e raised to 4y dy. Now, in this case, we know that the rule that could be applicable, no, in this type of function is the integration of eu du, which is equal to eu plus c. Now, in this case, since we have constant 5, then we can move 5 outside of the integration. Then we can rewrite the equation as 5, the integration of e 4y dy. However, before we can apply this rule, we need to identify first which is u in this case. Now, we know that our u in that case is equal to 4y, correct? Since this is our u here from our general form e raised to u. Now, our du, if we derive 4y, that would give us 4 dy, correct? However, since we only have dy in the integrand, then we introduce multiplier, that is 4. Our equation has changed upon putting a multiplier in the function or in the integrand. So in that case, we need to come up with a multiplier outside of the integration that is reciprocal to this number. In that case, we need to multiply 1/4 outside of the equation. Why? It's because since if we multiply 1/4 and 4, that would give us 1. That would lead us to the conclusion that our equation has not been changed because as if that we are multiplying 1 in the equation. Tama? Any number multiplied by 1, that is still the number itself. So in that case, since we have already satisfied this rule, that is e u, this one now is our du. This rule has been satisfied by our functions. So in that case, we can now finally use this form, and that would give us, since we have 1/4 outside of the equation, then we have also 5, then that can be written as 5 over 4, correct? Then we have e raised to u, that is e. Now our u in this case is 4y. Then we write 4y as the exponent plus c. So this is now the final answer, or the integration of 5e raised to 4y dy. So if you want to integrate this one, that would give us this value here. Now we have second problem, that is the integration of 10 over 2x minus 5 dx. You might think that power rule can be applied to this type of problem since we just need to transfer 2x minus 5 in the denominator by changing the sign. So we could um, write this formula into 10 raised to 2x minus 5 raised to negative 1 dx, correct? However, take note, if this is our u, then this one could be our r. But take note, in applying the UR du or power formula in integration, it should be noted that our r here should not be equal to negative 1. Our r should not be equal to negative 1. So therefore, we cannot apply power rule to this problem. Gets? I hope it makes clear. So we can try to check whether it satisfies the integration rule, that is the integration of du over u, and that is the natural logarithm of u plus c. So let's check. Now in this case, our u is 2x minus 5 because that's the only number in the denominator, correct? So that is 2x minus 5, that is our u. So our u in that case is 2x minus 5. Then we get the derivative of u, the derivative of 2x minus 5, that would give us 2 dx. Okay, now actually we can rewrite this function as we can move 10 outside of the integration. That could give us 10 integration, then put dx in the numerator, that's dx over 2x minus 5. Now take note, if this one is our u, then our du should be the numerator. Our du should be the numerator, since our du in this form is on the denominator. So however, since the required du is 2 dx, we need to have 2 in the numerator, correct? So we introduce again a multiplier, that is 2, and multiply 1/2 outside of the function or the integration, that is multiplied here 1 over 2. Again, so that if we multiply 1/2 and 2, that would give us 1. Okay, so the function has not been changed. The value of the equation has not been changed. So in that case, we have now our du in the numerator. So we have now du in the numerator. So we have satisfied this form already, that is du over u, right? That's du over u. Then we can finally use this form, and that we can. However, take note, we have 10 over 2 outside of the integration, so we can write that by 10 over 2. Then we have the natural logarithm of u. We have the natural logarithm of what is our u in this case. Our u is 2x minus 5. That is 2x minus 5. Then plus the arbitrary constant c. But you can simplify 10 over 2. That is 5. That is the natural logarithm of 2x minus 5 plus c. So this is now the integration of 10 over 2x minus 5 dx. We have example number 3. We have the integration of 5x e raised to 4x squared dx. So we can use the equation or the integration rule, that is the integration of e raised to u du, that is eu plus c. Now in this problem, we have u here that is equal to 4x squared. That is the exponent of our exponential. Okay, now we have constant 5. We can actually move 5 outside of the equation. That could give us 5 integration of x e 4x squared dx. Now this one is our u, but du here should be 8x dx, so the derivative of 4x squared. Okay, that would give us 8x dx. But take note, we only have x dx as our du. So if we rewrite the equation, that would give us e raised to 4x squared. Then we move x beside dx, x dx. So this one is our du, but we are lacking of 8 in the du section. So therefore, we need to have a multiplier again, that is 8. So that is now 8x dx, correct? Then we introduce the reciprocal of 1/8, that is 1 over 8, outside of the function. Since we have satisfied already the form EU du, then we can now use this exponential rule. So we have now satisfied this EU du rule, in which this entire term is now our du, correct? Since our required du is 8x dx, so we introduce 8, then we multiply 1 over 8 outside of the function, right? So we have now our answer. Since we have constant outside of the integration, then we rewrite that as 5 over 8. Then we have e raised to u, that is e raised to 4x squared plus c. So this is now the integration of 5x e raised to 4x squared. Now we have example number 4 here, that is the integration of 6x minus 2 over 3x squared minus 2x dx. Again, we cannot use the power rule into this equation by moving the denominator to the numerator and change the exponent into negative. Since our exponent here is -1, if we move that, then again, one of the consideration in applying the power rule is that our r there should not be equal to -1. We don't have other rule to this except partial fraction or the natural logarithm rule in integration. Partial fraction, by the way, it's much complex process in integrating, especially function that can't be integrated using the existing rules that we have. Our rule that could be applied to this one is the integration of du over u. Now in that problem, our u is equal to 3x squared minus 2x, the entire denominator. Okay? Our u. We have the derivative of 3x squared minus 2x, or that is the derivative of u, that is 6x minus 2 dx, which has been already satisfied by our original function. Take note, if we rewrite this function, we could have 6x minus 2 dx over 3x squared minus 2x, in which this one is our u and this one is our du, which satisfies the required du from deriving 3x squared minus 2x, that is 6x minus 2 dx. So in this case, we may not introduce a multiplier, okay? We can actually use directly this rule, which is the integration of du over u, that is logarithm or natural logarithm of u plus c. Okay, so it has this form has been satisfied by this function by not introducing a multiplier. Again, since it has been already satisfied, since this rule has already been satisfied by our original function. So the integration here is natural logarithm of u. Then we have our u, that is 3x squared minus 2x, correct? 3x squared minus 2x plus c. This could be our final answer, but we can actually break it down into a simpler form. Now we know that if we can factor out x in this case, correct? That is, we could have x times 3x minus 2, then plus c. So we have two terms, but using the rule of logarithm, that if we have natural logarithm of ab, that we could actually break that into natural logarithm of a plus natural logarithm of b. Or if we have natural logarithm of a over b, then we can we can rewrite that into natural logarithm of a minus the natural logarithm of b. So we can apply this rule in this function. Ensure that it has been discussed to you in your trigonometry or your algebra, I guess. So we can divide it into natural logarithm of x plus the natural logarithm of 3x minus 2 plus c. This is our simplest form for the integration of 6x over 6x squared minus 2x. So we could have other way of integrating this function. We could use partial fraction. So if you want to learn partial fraction, I have video in my channel, so you can watch them anytime. Okay, we have example number 5, that is the integration of 4x minus 8 over x squared minus 4x plus 1 over e raised to 3x dx. Now, since we have two terms, we can integrate them individually. So we can write our function as the integration of 4x minus 8 over x squared minus 4x dx plus the integration of 1 over e 3x dx. So let's begin with the first term. We have 4x minus 8 over x squared minus 4x. So we can use partial fraction, but we could also use the rule du over u, that is the natural logarithm of u plus c. Now in this case, our u is x squared minus 4x. Our du is the derivative of x squared minus 4x, that is 2x minus 4, then dx. And this should be our du in the integrand. However, take note, we have 4x minus 8 in the numerator, in which the required should be 2x minus 4 dx. But we can factor 4x minus 8 by taking their common factor, which is 2 outside of the integration, that is 2x minus 4. Tama? You factor out 2 in that case, since if you multiply 2 times 2, that would give us 4. 2 times 4, that would give us 8. If you distribute 2 inside the quantity. Correct? So you just factor out 2, then over x squared minus 4x dx. Then you rewrite the second term. However, since we have e over 3x in the denominator, we can move that up by changing the exponent into negative. That could be e raised to negative 3x dx. Tama? But let's start with this one first. So we have 2. We move 2 outside of the integration in that case. Then dx. Since our du is 2x minus 4 dx, then in the numerator we have 2x minus 4 dx, then we have satisfied du in this form. So this now is our du, and this one is our u, in which we have satisfied du over u. So we can now use this one, ln u, natural logarithm of u plus c, without introducing a multiplier. Again, we may not introduce a multiplier, since this one has already been satisfied by this. We are done with the first term. Now in the second term, we have e raised to negative 3x. So the rule that we could apply to this function is the e raised to u du, that is e raised to u plus c. Now in this case, our u is negative 3x. Then our du should be negative 3 dx, correct? However, this our u, now our du in this case is only dx. So we multiply negative 3 in the integrand, since we should have negative 3 as du. This is now our du, the required du by deriving negative 3x. However, since again we multiply negative 3 inside the function, then we introduce, or we multiply the reciprocal, that is 1 over negative 3 outside of the. So to simplify, we have answer. We have the first term, that is natural logarithm of u plus c, but we have 2 outside of the function, then we write 2. Then we have the natural logarithm. Our u is x squared minus 4x. Since In the second term, we have 1 over negative 3, but we have positive in between, so we can, since if we multiply positive and negative, that would give us negative, so we use negative as our sign. Then we have 1 over 3. Then e raised to u plus c, we have e, our u is negative 3x. That is negative 3x. Then we have plus c. Okay, so however, this one, we can make it into simplest form. That is, we can factor out x. Then the remaining would be x minus 4. So review your algebra on how to factor binomial or factor polynomial. So we continue, minus 1/3 e raised to negative 3x plus c. Again, we can divide it into two terms, but we have 2 as the coefficient, so we rewrite 2, the natural logarithm of x. Since it is multiplied, then we use plus. Then again, we have 2, we still have 2, the natural logarithm of x minus 4 minus 1/3 e raised to negative 3x plus c. So this is now the integration of 4x minus 8 over x squared minus 4x plus 1 over e3x dx. Okay, we have example number 6. We have the integration of 1 over 2x plus 3 e raised to 3x over 1 minus e3x dx. So in that case, we have two terms. Again, we can integrate them individually by rewriting our equation into the integration of 1 over 2x dx plus the integration of 3e3x over 1 minus e3x, we have dx. So we have two terms, so let's start with the first term here. So you might think that we could use power rule to this, such as we have ur du that equals 2 u raised to r plus 1 over r plus 1 plus c. By changing or by moving 2x in the numerator, we have 2x raised to negative 1 dx. So therefore, in this case, our r is negative 1. But take note, we cannot use r as negative 1, correct? We cannot set r as negative 1. So therefore, this should not be done, okay? So hindi to pwede. So it violates the rule. It violates power rule. So in this case, the only formula that we could use is the integration of du over u that is equal to the natural logarithm of u plus c. In this case, our u is 2x, okay? That is our u. Therefore, our du is the derivative of 2x, it is 2 dx, correct? But in the numerator, we only have dx. So we can move dx in the numerator. We can rewrite our function as dx over 2x. Now, we are lacking of 2 in the numerator, so we introduce 2 and 1 over 2 outside of the integration. Tama? So, therefore, this one now is our du, and this one is our u. So, we can now use this rule, which is natural logarithm of u plus c. So, we have the answer that is 1/2 the natural logarithm of 2x, that is our u. Now we have second term, that is 3e raised to 3x over 1 minus 3x dx. So upon checking the equation, if our u here is 1 minus e3x, then our du should be what? That is negative 3 e raised to 3x dx. The only thing that we will be deriving, if we want to derive e here, is the exponent. From the rule, if we derive e raised to u with respect to dx, that would give us e raised to u du dx. Correct? Now in that case, since derivative of 1 is 0, we only have e raised to 3, negative e raised to 3x as the only term that we could derive. So in that case, if we derive e raised to 3x with respect to dx, then we use e raised to 3x, then the derivative of 3x with respect to dx, and that would give us e raised to 3x. The derivative of 3x with respect to dx, that would give us 3. So therefore, we have 3e raised to 3x. Correct? So as a review lang, or just a slight recap of your differential calculus. So take note, upon checking the numerator, we have 3e3x dx. Correct? And the required du should be negative 3e raised to 3x dx. So the only thing that we are lacking in the numerator is the negative sign. So we multiply negative 1 here, correct? So that we could satisfy this rule. So this one now is our du. And this entire term is our u. However, we multiplied negative inside the integration. So again, we multiply 1 over negative 1 outside of the integration. And that would give us the rule du over u. Tama? So we can apply the integration of du over u, since again that is du over u. So therefore, we have the same rule, that is natural logarithm of u plus c. So we can rewrite, or we can have the answer for this term, that is negative 1, okay, since we have plus positive here times 1 over negative 1, that is negative 1, so negative times positive, that is negative, so we have negative 1. Then since it is du over u, then we have natural logarithm as our integration. So we have natural, so we may not write 1 as a coefficient, so we can directly write natural logarithm of our u. And in this case, our u is 1 minus e raised to 3x. That is 1 minus e raised to 3x. Correct? Then, we have plus the arbitrary constant c. So this is now the integration of 1 over 2x plus 3 e raised to 3x over 1 minus e raised to 3x dx. And that ends the discussion for the exponential rule and the natural logarithm. So thank you for listening, and for more videos, don't forget to like and subscribe, or hit the notification bell for more updates. Thank you.